Hello everybody. So yesterday you learnt how to solve a two-step word problem. So today we're going to have a go at solving some. I'm just going to share our learning objective for today's lesson. Today I'd like you to solve two-step problems. That's what we're learning to do today. First success criteria is to identify the first and second step like you did yesterday. Then you'll need to be able to calculate the first step and then calculate the second step. So let's have a quick recap of what we did yesterday. Here is a word problem. Drew has 58 pieces of candy. He gives 17 pieces to Charlie. He gives 14 pieces of candy to James. How much candy does Drew have left? Okay. The first thing I would like you to do is identify the first and second step by drawing out the problem or representing it in a bar model. Pause the video now, off you go. Have you done that? Well done. So I could draw the problem out by looking at each part of the information. So the first part is Drew has 58 pieces of candy. So I might draw a bag of sweets and put 58 in there. So I know he has 58 pieces of candy. The next piece of information is that he gives 17 pieces to Charlie. So I know that the word gives means I'm subtracting because an amount is being taken away. So he gives 17 of those pieces to Charlie. So the first step is that I need to subtract 17. He then gives 14 pieces of candy to James. So then he needs to subtract, he's going to give 14 pieces to James. So my second step is to subtract 14. And the answer will be how much candy Drew has left. Okay, if you represented that in a bar model, then we would know that 58 is the minuend. So 58 is the total at the top. And there are three numbers that make 58. One of those will be 17, one of those will be 14, and then we have our question mark. So this part of the bar, we need to find out what that is, and then we can subtract that from 58. So there are two ways of doing it. We could do 58, take away 17, and then take away 14. Or we could do 17 add 14 to give us a total here, and then 58 take away this. That's up to you which way you do that. So then we need to have a go at solving the problem now. Now we know what we've got to do, we need to solve the problem. So I'd like you to pause the video now and solve the problem. Find out how much candy Drew has left. Off you go. Have you done that? Well done. So we could do it this way first. This is one way of doing it. 58, take away 17. I know that 8 ones take away 7 ones gives me 1 1, and 5 ones take away 4, 5 tens take away 1 10 equals 4 tens. So the answer is 41. So I've done the first step. Now I need to do the second step, and I need to take away 14 from the answer. So 41 sweets left, and then I'm going to take away 14 sweets. Okay, so I know I'm going to have to regroup here because I haven't got enough ones to take away. So I could do a pictorial jotting, or I could use an empty number line. I'm going to use a number line. Start with 41, and I'm going to take away 14. So I'm going to take away the 1 first to get me to 40. Now I need to take away 3 more, which will make my 4 ones, which takes me to 37. And now I need to take away 110, which gives me 27. So the answer is 27. If you did it in this way from the bar model, then we would have to add up the amount that has been given away first of all. So 17 add 14. 17 add 14 equals, so I know that 7 and 3 make 10, so 7 and 4 must make 11. So I've got 1 10 and 1 1. Then I've also got these 10s to add here. 10, add another 10 is 31. So I now know that this part of the bar is 31. And I'm going to do 58, take away these parts to leave me with this bit. So 58, take away 31. I know that 8 ones take away 1 1 is 7 ones, and 5 10s take away 3 10s is 2 10s. So I've got my answer, 27. That's how many sweets Drew had left. So there's two ways of doing that. Doing it through a bar model or looking at the steps by drawing out the problem. It's up to you how you do that, which way makes more sense to you. Okay, let's have a go at one more together. Here is a two-step problem. Pam baked 26 cupcakes in the morning and 28 cupcakes in the afternoon. 13 cupcakes were left over at the end of the party. How many cupcakes were eaten? I'd like you to pause the video now, find out what the two steps are, and then have a go at solving the problem. Off you go. Have you done that? Well done. Okay, I'm going to have a go at drawing the problem first for those of you who did that, and then we'll have a look at the bar model. So Pam baked 26 cupcakes in the morning. So we could do a tray of cupcakes. And we know that she baked 26. And then she baked 28 cupcakes in the afternoon. So we'll do another tray of cupcakes, and this time there were 28 cupcakes. So we know that we want to find out how many cupcakes were there, how many cupcakes Pam made all together. So we know that we are going to need to add those together to find out how many cupcakes there were. So the first step we need to do is 26 add 28. The next part of the information says that 13 cupcakes were left over at the end of the party. So it was a party that happened, some of them were eaten. Maybe we could draw a mouth here. Some of them were eaten at the party and 13 were left over. Okay, so some of them have been subtracted, but we don't know how many. And 13 were left over. So the second step would be to use, because we've got a missing number in the middle, we need to use our inverse. So it might be helpful at this point to find out 26 add 28 first of all, so that we can do our missing number problem. So let's solve the first step first. 26 add 28 is 54. So 54 cupcakes were made. Take away something equals 13. So we've got our missing number problem there, so we can pop that into our bar model to find out what we've got to do. 54, take away something, equals 13. So we know now that we need to take away 13 in order to find out that missing number. So 54, take away 13 equals, so our second step was to take away 13. 4 ones take away 3 ones is 1 1, and 5 tens take away 1 10 is 4 tens. So the answer is 41 cupcakes were eaten. Now that was quite a tricky problem to solve because it meant that you had to use your inverse as well. So we've gone through that one in case you have ones in your challenge that you choose where you've got to really think about it, because there might be, you might have to use your knowledge of inverse as well. Okay, drawing out the problem helps you to understand what you've got to do. So it's now time for you to choose a challenge. Choose challenge 1 if you're feeling a bit unsure about the question that I've just gone through here and the use of inverse, and choose challenge 1 where you'll just be focusing on addition and subtraction 2-step word problems that were more like this one at the beginning. Okay, choose challenge 2 if you'd like questions that are a bit more challenging, and if you feel that that's still maybe not as much of a challenge that you would like, then have a go at the challenge 3 investigation on the class page. I'll show you that now so that you know what that is that you've got to do there. So the investigation that I'd like you to have a look at for challenge 3 is called Sitting Around the Party Tables. So you're at a party and sitting around the table with 7 friends. So you're here, so there's 8 of you all together sitting around the table. At the top left-hand corner is the friend who's giving the party. She or he has a bag of sweets and starts giving them out in a clockwise direction. So she starts here, gives 1 sweet to that person, 2 for the next person, 3 for the next person, 4 for the next person, and so on. There are other similar parties going on at the same time. They have bigger tables with more children sitting on each side. So the investigation is to explore and compare all of the tables. When you've got 2 children sitting on each side, when you have 3 children sitting on each side, when you have 4 children sitting on each side, and when you have 5 children sitting on each side. So the things you could look at are the total number of sweets that children sitting opposite each other have. So the total here, the total here, the total here, and the total here. Is that always the same on each kind of table? The total number of sweets needed for each size of table. How is that different? Can you spot any patterns? The total number of sweets belonging to children who are diagonally opposite. So these 2 children and these 2 children, can you spot any patterns there? And that is what I'd like you to get to for just to that bit. See if you can spot anything interesting, spot any special patterns within those questions. If you would then like to have a go at the optional extension at the ends, if you haven't had a go at challenge 3, then have a go at that as your extension, okay? But if you did do challenge 3 and you want to extend that even more, then have a think about 5- and 6-sided tables. And are you able to predict the number of sweets that would be needed from what you've found out so far? Are you able to predict what might happen with children sitting opposite each other or children sitting on the same side? Really have a think through that problem that your challenge is. So good luck. Remember to draw out the problem to help you identify the steps. Use the bar model if you feel confident to do that and you feel that that helps you. And I can't wait to see how you get on. Good luck, everybody. Bye.